What is the first step in the conventional design of raft is finding the loads acting on the columns q1, q2, q3, q4, q5, q6, etc. Then self weight will also act, but we will not consider in the conventional design method. Second step is finding the contact pressure. To find contact pressure, two cases may happen. One is there is no eccentricity. Second case is with eccentricity. First, without eccentricity of loads, the load will be acting exactly at the center of the raft. The total load will be acting at the center of the raft, because that is the assumption made in the conventional design method. Then the load pressure is equal to load by area, resultant load by area of the mat. Okay, if eccentricity comes into picture, then uh, sorry, if the eccentricity comes into picture, then the formula is this: pressure is equal to Q by A plus or minus QE by IYY x plus or minus QEY into y divided by IXX. When you see this, no, Q is the resultant loads, A is the area of the mat, and EX and EY. EX and EY, when you take a mat, we have both thickness as well as length. மேட் எடுத்திங்கன்னா அது ஒரு ஸ்லாப் மாதிரி. when you take a slab, it will have a length, width as well as thickness. So when you talk about the length, x direction, x direction la if eccentricity happens, then also y direction layum eccentricity can happen. So that's why we have QEX uh, by IYY into x plus or minus QEY y by IXX. இதில் வந்து QE அப்படிங்கிறது என்னது? மொமெண்ட். It's nothing but moment. Mx divided by Iyy. That is only it is written as QEX into x divided by Iyy. X is the x is the eccentric distance. Okay, so we learned the formulas. So the maximum contact pressure should be less than the allowed soil pressure. Okay, the allowable soil pressure will be given at first itself, and the pressure, contact pressure we are finding in the second step, should be less than the allowable pressure. That we should keep it in mind. Like அது இதுக்கு முன்னாடியெல்லாம் நம்ம செக் பண்ணுவோம்ல, லாஸ்ட் ஸ்டெப். when you check the pressures, the checking pressure should be less than the given allowable pressure, the same. Then the third step is you have to divide the mat foundation into small strips in both x direction and y direction. What is that small strip அப்படின்னா, why we have to divide the slab into strips அப்படின்னா, we are going to resolve the we are going to divide the total mat into small strip, so that each strip will act as a beam. ஒவ்வொரு பீமாக நம்ம பிரித்து, ஸோ பீமோட டிசைன் ப்ரொசீஜரை we will use later. Okay, so for that purpose we are going to divide the mat foundation into strips. When you see, this is the top view of the mat foundation. The total length of the mat is capital L, and the total width of the mat is capital B. Okay, and when you see the mat, you can see the loads Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9. You can see that, and they are columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns are there inside the mat, and the 9 columns loads are acting: Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9. As you see, the total load is not exactly acting at the center. The exactly at the center na எதில் act ஆகணும்? Q5 la actually the total load should act, but it will not act exactly at the center. Here there is a eccentricity observed from the center. The total resultant load acts away from the center. You can see here the the total load acts away from the center. Centerலேருந்து it is at a distance of exx in the x direction and ey in the y direction. X directionல eccentricity is ex and the y direction the eccentricity is ey. Now second step, after this we should divide the slab into or the mat into strips. You can see the strips. The strips தான் ஹரிசாண்டலாக லைன்ஸில் காமிச்சிருக்காங்க. Q1, Q2, Q3 is one strip. Q4, Q5, Q6 acts in one strip. Another third strip is Q7, Q8, Q9 is another strip. That's why B1, B2, B3. You can see B1, B2, B3. Y directionல 3 ஸ்ட்ரிப்பாக டிவைட் பண்ணியிருக்கோம். B1, B2, B3. So B1 is going to B1 by B is going to one strip. B2 by B is going to another strip. B3 by B is going to another strip. Each will act like a beam. 3 beams totally. இந்த அப்புறம் வந்து பீமை எப்படி நம்ம ரிசால்வ் பண்ணுவோமோ அந்த மாதிரி ரிசால்வ் பண்ணால் போதும். ஸோ for that easy purpose of design we are going to divide the mat into beams. Okay. Now beamsனாலே first step என்ன வரும்? We will find the reactions. After finding reactions we find the shear force and draw the shear force diagram. And when you take அடுத்து என்ன கண்டுபிடிப்பீங்க? Bending moment diagram. Then you find the bending moment and you draw the BMD. So that is what it is done in the next step. And in the fifth step we find the modified column loads. Now what is modified column loads அப்படின்னா okay, when you take about the strips will not act இது நம்ம ஸ்ட்ரிப்ஸை டிவைட் பண்ணுறோன்னு I said, right? We are dividing the mat into small strips so that each strip will act like a beam. Now அப்போ பீம் மாதிரியே தான் இருக்குமா, இதில் எந்த டிஃப்ரென்ஸும் வராதான்னு கேட்டால் அப்படி வராது. லாஜிக்காகவே பார்த்தோன்னாலும் when you see it logically also, though we divide it into 3 strips, all the 3 strips are interconnected. Though Q1, Q2, Q3 are in one strip, the effect of the load in the Q4, Q5, Q6 will act on this first strip. Similarly, the effect of the load in the third strip will be there on the second strip. They are not independent, they are all dependent, they are all actually connected. So logically the effect of the other loads will be there in this each strip. ஒரு ஸ்ட்ரிப்புக்கு இன்னொரு ஸ்ட்ரிப்புக்கு மேலே இன்ஃப்ளூயன்ஸ் வில் பி தேர். ஸோ they are not actually independent. So we have to find another parameter and that is called modified column loads. Modified columns loadsனா Q1, Q2, Q3 மட்டும் ஒரு ஸ்ட்ரிப்பில் லோட் ஆக்ட் ஆகாது. The effect of the other loads in the other strip will be there on this Q1, Q2, Q3 strip. So we should find that effect. That effect is found using the term called modified column loads. So how to find this modified column loads? Next step, consider the first strip. The first strip carried a load of Q1, Q2, Q3 and the width of the first strip was B1 and the second strip oda width B2, third strip oda width B3. I said that already. So width of the strip is B1 and the length of the strip is B, capital B, and the pressure acting on the strip will be assumed to be Q average. Q average. Now listen to the picture. Picture பாருங்க. This picture is the reference. See, the first strip is taken. The first strip is, the width is B1, length is B, and the loads acting on the first strip are Q1, Q2, Q3. And assume the soil pressure. Beam, small beam போட்டு ஒரு picture is drawn with arrows, many arrows, parallel lines. Pressure, contact pressure distribution தான் அது. And it is the allowable pressure is average. Q average is considered. Okay, these are considered. Now we will resolve the forces. We will resolve the forces. Okay. So the average load on the strip is, when you take the average load on the strip, Q average. What is the load? என்ன சொல்லுவோம்? Total load is, can be written as downward load plus upward force. இந்த ரெண்டையுமே when you add it, you get the total load. Now average you put the downward load plus upward load divided by 2, since it's the average load. Okay, what are the downward loads in the first strip? We are considering only the strip now. Okay, so in the strip, what are the downward loads? First strip, Q1, Q2, Q3 are the column loads acting downward. So Q1 plus Q2 plus Q3 is going to be the downward loads, plus upward force. Upward force will be the resistant force. What is the resistant force always? Soil force. Soil oda average pressure எவ்வளோ கொடுத்துருக்காங்க? Q average is given. Soil pressure QAV. Now it is in pressure, which is unit is kilonewton per meter square, but we need upward load. Upward pressure is QAV. Now we need upward load actually. So how to convert stress into load? We multiply the stress with area, so that kilonewton per meter square into meter square will give you kilonewton, which is the load. So upward load is equal to upward force, which is QAV, into area. What is the area of this plan area? Plan area of this strip, B1 by B. Width of the strip is B1, length of the strip is B. So B1 by B will be the area. So multiply the given pressure QAV into area, that will be converted into upward force. So average load is equal to upward load, that is QAV into B1 into B1, plus downward load Q1 plus Q2 plus Q3, since it's average load, total divided by 2. 1 by 2 we have to multiply. So this is average load on the strip. Next is, we should find the modified soil pressure. Q average is Q average is the normal soil pressure, average soil pressure, but we should find modified average pressure. Modified average pressure is due to the effect of other strip on this strip. So அதுக்கு என்ன பண்ணணும்னா, you should multiply the given pressure, that is QAV, available pressure QAV, into multiply the given pressure into ratio of upward total average load divided by upward load. Total average load divided by upward load. Upward load தான் என்ன கண்டுபிடிச்சு வச்சுருக்கோம்? QAV into B1 into B2. So Q average by, that's the formula, to Q average load divided by upward force into the given available pressure. That will give you modified average soil pressure, and we will find modification factor. இதை கண்டுபிடிக்கிறதுக்கு தான் இந்த ப்ராசஸ்க்கே we are going. So modified column modification factor is given by the letter F, and F is nothing but QAV divided by the downward force. What is the downward force or the downward load? Q1 plus Q2 plus Q3. So Q1 plus Q2 plus Q3. Whereas in this previous formula, see, QAV, total pressure, average load divided by upward force. Here total load QAV, average load QAV divided by downward force. Okay, remember this formulas. So we find the modification factor. So in the F வச்சு என்ன பண்ண போறோம்? What are we going to do with this F na? We will multiply this F to the individual loads. So we know the column loads are Q1, Q2, Q3. Now you multiply to the individual loads, it will become FQ1, FQ2 and FQ3. So these are the modified loads. Now what is F? Fக்கு தான் அந்த ஃபார்முலா டிரைவ் பண்ணியிருக்கோம். ஆவரேஜ் லோடு டிவைடட் பை டவுன்வர்ட் லோட், that is QAV divided by Q1 plus Q2 plus Q3. Okay, now we will find the, again we will redraw the bending moment diagram and shear force diagram using this new loads. New loads are modified column loads. Using this we will find the average bending moment diagram and shear force diagram. So and then you design for the raft reinforcements like the beams madri, then you can do this. Okay, so this is the procedure for uh, this is the procedure for finding mat foundation design. Okay, so this is the procedure for proportioning, and you don't have problem in this, only the procedures have been passed for generations. Then the last topic of this unit is floating foundations. When you talk, many many competitive exams you can expect this question, floating foundation. Even for engineering services, Indian engineering services, this question is asked. Floating foundation. Floating foundation na, will the foundation float in air? No, it will not float. Or only ship can float in water and aeroplanes can float in air. But the land வந்து nothing can float. Foundation cannot float. It will sink or drown. So floating, when you talk about floating foundation, what does it mean? Which means it is a very tricky name for the foundation given. It is not a type of foundation. It is not at all a type of foundation like mat foundation, strip foundation, strap foundation. It is not at all a type of foundation. That you should remember. It is not a type of foundation. When you talk about floating foundation, it is a condition in the foundation. Okay, what is the condition means, when you see the trees, no, when you see the coconut tree or long tall trees, that how much length they are going, எவ்வளோ டாலாக வளருதோ அவ்வளோ டீப்பராக the roots will be there. The how, when you see the big trees, long tree, huge trees, how much height or taller it grows, the roots will also be deeper in that way, in that length. So this is the lesson that we learn from nature. The nature tree shows how much taller the tree grows, that much deeper the root goes inside the soil. Similarly, if your building is going to be very tall, then you should consider, if the, for example, if your building is going to be 100-meter tall, then you should construct a foundation which is 100-meter deeper into the soil. But practically 100 மீட்டர் மேலே கூட டெவலப் பண்ணிடலாம். சாயிலுக்குள்ளே 100 மீட்டர் போடுறது எப்படி? டனல் பண்ணி போடணும். That is very huge budget. That is very risky also. When you excavate the soil beyond certain limits, total collapse of soil will happen in the surrounding areas. So we cannot just like that excavate the soil for 100-meter depth just because your building is going to be 100-meter tall. So but actually this is a hypothetical situation of foundation. Idea of foundation where the weight of the building superstructure is equal to the weight of the substructure, or the height of the superstructure can, or அது வந்து டெக்னிக்கலாக they explained as the weight of the superstructure is equal to weight of the substructure. Okay, for example, சிம்பிளாக சொல்லணும்னு வச்சுக்கோங்க. if a person is 50 kg and she was asked to carry a person of 100 kg, can that person carry a person of 100 kg? Not at all. But can a 100 person அதே மாதிரி தான், if the soil is very weak and it cannot carry a 100 kg building, it cannot carry a big building if the soil is very weak. So the idea is, இதுவும் 100 kg, the person they have to carry also 100 kg. அப்படி வச்சுக்கிட்டோன்னா the effect is nullified. அந்த மாதிரி ஒரு ஐடியா தான் floating foundation. Okay, that idea is floating foundation. It is also called fully compensated foundation, and the settlement is going to be zero here. Settlement ஜீரோங்கிற ஒரு கண்டிஷனே வராது. It's ideal situation. It's ideal situation where settlement is going to be zero. But here, this idea of floating foundation, the settlement is going to be zero. And when you talk about definition of floating foundation, the weight of the building is equal to the weight of the soil or the weight of the foundation substructure. How much you remove or how much the weight you impose, so avlo weight of soil is removed. Okay, and it is put with the weight of soil is removed na enartham, weight we are going to replace the soil with foundation. Foundation is a concrete material. ஸோ எவ்வளோ எக்ஸ்கவேட் பண்ணுறோமோ அந்த இடத்துல அவ்வளோ காங்க்ரீட் போடுறோம். போட்டுட்டு அதே அளவுக்கு மேலே வெயிட் ஆஃப் பில்டிங் போடுறோம். இன் சிம்பிள் வேர்ட்ஸ், the weight of the superstructure is going to be equal to weight of the substructure. Then settlement is going to be zero. But economically and feasibility wise, it is not at all possible. Why? The same thing. There is no settlement. So assume the weight of the building as Q and weight of the soil excavated as WS, and the excess load on the foundation is QE. In floating foundation, the weight of the building is equal to weight of the soil excavated. Weight of soil excavated na enna artham? What is the meaning? We are going to எவ்வளோ எக்ஸ்கவேட் பண்ணுறோமோ அவ்வளோத்துக்கு உள்ளே என்ன போட போகிறோம்? காங்க்ரீட் போட போகிறோம். That is the indirect meaning. So weight of the soil excavated. So weight of the building is equal to weight of the soil excavated. Q is equal to WS in case of a floating foundation. Okay, now we'll see the formulas. In case of raft in place, in case of raft foundation, the safe bearing capacity governs the design. Okay, but the settlement pressure is also uniform. So floating foundation derivation சொல்லலாம் the formula. When you calculate a settlement, what is SBC? If you recall the second unit, SBC எப்படி கண்டுபிடிப்போம்? net safe bearing capacity. Net safe bearing capacity is equal to load by area Q by A minus gamma D. So Qn is equal to Q by A minus gamma dF. This is first equation. Now find factor of safety. Factor of safety is net ultimate divided by net safe. We know that ultimate load divided by working load is equal to factor of safety. Similarly, here ultimate bearing capacity divided by net ultimate bearing capacity divided by net safe bearing capacity will give you factor of safety. So net ultimate in the formula you have to memorize 5 into 1 plus 0.2 d by b into 1 plus 0.2 b by l cu by q by a minus gamma df. You should memorize this formula. Now in this formula, f is equal to qnu by qn. இதில் the net safe bearing capacity becomes 0. Assume q by a minus gamma df is 0. அசியூம் பண்ணுங்க. அந்த மாதிரி ஆச்சுதுன்னா என்ன ஆகும்? f is equal to numerator by denominator is going to be 0. Then f factor of safety is going to be infinity. Any number divided by 0 is going to be infinity. So the factor of safety infinity இருந்தால் safety is infinite safety. அப்படின்னா நீங்கள் சேஃப்டியை பற்றி யூ டோன்ட் ஹாவ் டு ஒரி அட் ஆல். கரெக்ட்? ஆல்சோ வி நோ தட் ஃபேக்டர் ஆஃப் சேஃப்டி அதிகமாக த மோர் த ஃபேக்டர் ஆஃப் சேஃப்டி, த the projectோட price is also going to be more. The economical situations is also going to change. The budget is going to hike up if the factor of safety is more. So factor of safety infinity ஆச்சுதுன்னா, then it is a ideal situation where it is completely safe. எப்படி நீ பில்டிங் கன்ஸ்ட்ரக்ட் பண்ணாலும் it is going to be completely safe. So floating foundation ஓட ஐடியா இதுதான். The numerator is made to be 0. So the factor of safety becomes infinity. Okay. So that is the main idea for uh, 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 main idea for floating foundation. So இது 0 ஆச்சுதுன்னு வச்சுக்கோங்க. Qn is 0. Substitute Qn is equal to 0 in equation 1. What will happen? Q by A minus gamma df is equal to 0. So what is df? df is equal to Q by A divided by gamma. Q by A, Q by A gamma. The formula like Q first equation, like if you substitute Qn is 0, factor of safety is going to be also infinity. Also Qn is 0 na depth of the foundation df is equal to Q by A gamma. So df is equal to Q by A gamma வா இருக்கும்போது, so that depth, if the depth of the foundation is taken to be Q by A gamma, then it is going to be a zero settlement building, factor of safety infinity, and it is ideal situation, and it is called fully compensated foundation, or it is going to be the floating foundation. Okay, you memorize this factor of safety formula, and denominator 0 ஆகும்போது the factor of safety is infinity. Also when the denominator is 0, how that is Qn is 0. So first equation like Qn is 0 போடும்போது what is depth of the foundation? Q by A gamma. So that Q by A gamma ல depth of foundation fix பண்ணும்போது the foundation is going to be a fully compensated foundation, or it is going to be a floating foundation. Okay, so the same settlement is 0, factor of safety is infinity. And why floating foundation is adapted? If the soil is very weak and soil is prone to shear failure, and also if the main idea is we are spreading I said the weight of the substructure is equal to weight of the superstructure. So we are spreading the load to larger area. It is something like the idea is எவ்வளவு பெருசாக நீங்கள் வந்து கிரவுண்டுக்கு மேலே வீடு கட்டுறீங்களோ மண்ணுக்குள்ளே ஒரு வீடை கட்டணும், அந்த மாதிரி ஒரு ஐடியா. Okay, so the applied loads will be reduced and the soil will be carried to the weak soil through the stronger foundation. Okay, this is one of the best way to use floating foundation rather than pre-solutions. And the functions of the floating foundations are they reduce settlement because zero settlement is there. Also if the strong layer is absent at a reasonable depth, then their shear failure will not be shear failure or the shear stresses will be reduced. Okay, because we have a strong layer of foundation which carries the heavy load and transfers it to the soil. So this is the function of the floating foundation.